Okay, well, let's get started and talk about search so we can all go out and have some beers. So I'll try not to cut in too much to the rock bottom time here. We're going to do we'll take a look at Solr, and I imagine there are a handful of you guys in the room who have probably already even worked with Solr. You may already know it's for doing proper full text search in your web applications. So without further ado, my name's Nick. Hi, you might remember me from a few of my other talks around here. Last one I did, I think, was on configuring systems, cloud systems with Chef. A little bit of that may come into play later into this talk when we talk about running Solr in production. But for those of you who don't know me, I've been doing Rails for about 4 years now, full-time, since 2005, 5 years now. Come from a real generalist perspective. I've done just dozens on dozens of different client projects, and a couple of times through the years have had sites that need search. And typically the first place you start is just plain old SQL-like, throw a few wildcards in there, call it done. I see some heads nodding. You may also nod that gets kind of painful after a little while. If you start, once you make it out of staging and into production, you've got users actually using this now, and people are asking you, hey, why is the site so slow? Man. Yeah, so that's when you start looking into actual proper ways to do full text search. Another great thing about full text search is there are just things that you can do with that you cannot do with SQL-like, and we'll get into that a little bit more. So Solr specifically, the last 6 months or so I've been working on a project called Web Solr, which we do, I'll just get this plug out of the way, right out of the way, so you guys know my agenda here, but we do hosted Solr search, just kind of take all the pain out of setting up the servers and managing and monitoring and all that kind of stuff. So you get all the Solr goodness without having to worry about, where your config files are living and what happens if your server goes down. So yeah, coming from that generalist perspective, I have picked up a little bit more about Solr. I may not be a Solr expert quite yet, but certainly have had quite a lot of exposure to it recently. And so that's where my recent interest in it has come from. So what's Solr, and how can we make the most out of it? We'll start with just the concept of indexing. And you guys are, I'm sure, familiar with an index. You got a bunch of words in a document. You make a list of those words and where they show up in the document, so that later on, you've got a word in mind, you can go find where that word is, or what document that word is. Of course, being geeks, we take a simple thing and we make really cool things out of it, and make it a lot more complicated. So get into some of the complication. Lucene may also be familiar to you. It's been around the block for a while. It is a library that does indexing. It's written in Java, it's open source, it's awesome. If you were doing full text search, 7, 8 years ago, you were using Lucene. And this is the library where if you've got some text, you want to make an index out of it, you give it to Lucene. If you want to search that index, talk to Lucene. And so in that case, I thought that's what we were talking about. Solr does. What's Solr? Solr is a web application. It's kind of a RESTful interface to Lucene. You give your documents to Solr over an HTTP connection. That means that you don't have to speak Java in order to interface with Lucene. Solr will do that for you. All you have to do is speak HTTP. And yeah, Solr gives you different administrative options, so you can have multiple indexes, and lets you scale your data for the web. It does replication. It does lots of really interesting things, so that you can you can do searching on a web scale. So yeah, we still with me? Because we're going to get into some of the real technical stuff now. And speaking of which, I'm kind of blur Solr and Lucene. I'm not really going to make much of a distinction about Lucene beyond that little intro right there. Solr does extend Lucene in some ways, and I never really pay attention to who's doing what. So we'll talk about the schema. Solr and hence Lucene expect you to tell them about your data. You'll configure a schema to tell Solr what type of data that you're giving it. And so, data types. I'm not going to list all those, but they all look familiar to all of us, and we can handle these different data types in ways that are appropriate for those data types. Is essentially the idea behind defining a schema. Different kinds of processing will happen on a text field than will happen on an integer field, just by way of the data. One cool thing about schemas with Solr is you can use dynamic field names. And a lot of Solr clients out there will have their own default schema with kind of naming conventions. And being Rails programmers, we like conventions over configurations. So, for example, the Sunspot Solr client for Ruby has a really nice schema, and you typically don't really have to configure it all. So, don't let if the concept of writing an XML file to define all your data types kind of freaks you out, don't worry too much about it, because that's been taken care of in user land, and so you get all the benefits without the headaches. The text field type we'll talk about specifically because it does a lot of cool stuff, and I'll get to that in a second. One other interesting thing about the schema is that you don't have to define a unique key, but it comes in handy for a lot of different things. And we're kind of used to thinking about the unique key. Some of you may have an aha moment like, oh, that's cool, no unique key required. Well, you're probably working on different projects than I work on, because I don't really know why that's useful. But unique keys, obviously, they let you add and remove records individually. They let you do updates to a record you already have in the system, as opposed to doing all sorts of stuff wholesale. And obviously, it lets you correlate with an existing SQL database. So this text field type. This is a lot of the indexing related features that you get on a text field. And this is where most of the magic happens when you're dealing with indexed search. And a lot of these problems that you don't really think about, when you start with your SQL-like, it doesn't take long before you bump into something and you realize, oh yeah, I got to normalize the case that I'm searching with. Let's just kind of make everything lowercase on both ends, call it good. Solr and Lucene will do this kind of stuff for you. We need to normalize, you'll end up doing lots of regular expression transformations on your queries just to kind of generalize them a bit more, because users are expecting Google level flexibility on the querying. That just, seems so natural, but someone's got to implement those features for you. So these are a lot of the things that Solr will do. When you're indexing your data, it'll process it in a bunch of different ways, so that just to prepare your index to be searched in more intuitive ways. So we're talking tokenizing words, all these different things. Normalizing accented characters. That's like, if you've got an E with an accent over it in a word. Solr can take care of all those kinds of things and just build it as non-accented words in the index, so that it's kind of treating things the same way, whether or not your user is searching with accented characters or not. Some of my favorites are like synonyms. You can specify lists of synonyms. So if your particular application has terms that have similar meanings, you can specify that in a configuration somewhere, and Solr will expand those terms. It does runtime indexing or synonym processing and query time, but it'll expand that. So say you're building a legal database, you can make law and legal synonyms for each other, and a search for law will return documents where there's the word legal in it, things like that. Language stemming is a great one. English words have patterns of how they're put together, and that may mean you can search for the singular form or the plural form of the word, and Solr will treat them the same way. Or different verb conjugations of a word, and Solr can treat those the same way as well. Word shingles is a fun one. That's when you're taking a phrase with a bunch of words in it and have a certain number of consecutive words. So if you take the sentence, the quick brown fox jumps over the lazy dog, and take a word shingle and break it down to 2-word phrases. So you have the quick brown fox. All this kind of stuff that, I don't know about you, but I've probably implemented half of those features on my own in some of my early Rails sites, and had to bother with maintaining all of it, and it still didn't really perform all that well anyway. So yeah, that's the text field. It's great. You can index rich content in Solr. You can send in HTML documents, PDF documents, Word documents. Indexing PDF documents turns out to be fairly popular. And yeah, when you're adding or updating a record, this is some of the stuff that goes on. Your Solr client is serializing your documents, and this is typically actually the most time-consuming part of the whole process, surprisingly enough. Just fetching your data out of MySQL, building an XML or JSON document out of that. Solr supports a handful of other formats as well, but being in Rails land, XML and JSON are particularly relevant. But then you just post it over to a URL that corresponds with your index being hosted by Solr, and it does all the processing from there. So, pretty easy. So let's talk about querying. We've hinted at a lot of the querying syntax issues that you might stumble across if you try to build your own search engine. You know, for starters, we've got awesome Boolean logic on this stuff. You can include and exclude different terms. You know, you can target your various fields. You can, you know, say search for a certain value in a certain field. You know, think of the advanced search form on Google's homepage. You can target all sorts of different kind of stuff. And because your indexes are data type aware, like you've specified your schema, Solr understands your format, you can do data type aware querying. You know, that means when you're searching a Boolean field, you can tell it whether it's true or false. You're searching numbers, you can search for numeric ranges. You're searching dates, you can search date ranges. And I probably list a few of these in the next few slides. On your numeric fields, you can do min, max, average, standard deviation. You know, stuff that's pretty standard even in MySQL. But when you couple it also with, you know, the Boolean stuff, with, you know, some of the filtering that you can do, it all really adds up to some pretty powerful stuff. Date ranges in math, you can do date math relative to now. So I get some of that stuff. Querying with distance. Solr does spatial search, and that's probably one of the killer features for most Solr implementations. If you need spatial search, you are probably already using Solr. I think Sphinx might support it as well, so, but I'm definitely not a Sphinx expert. So yeah, I mean, send in latitude and longitude. Question? Okay, well, microphones or buy me a beer, or later. We'll get to questions at the end, I guess. Save on passing the microphone around. I'll kind of zoom through more of these features. Faceting. Make it easy to, you know, Solr can present to you all the different values that are present in the results, so that you can further refine your searches by the values present in a certain set that you're looking at. So say you're searching books, and you type in a title, and you get a bunch of books with a similar title. You know, you may have a facet of author. You want to just refine by a certain value for your author, or genre, or, you know, you name it. So Solr can present to you even all the options. So, you know, say you get 100 books back, it'll list you the 30 authors in that data result set. Other cool stuff, Solr can do spelling suggestions for your queries, and it can do like query suggestions based on popular queries that it's getting. Pretty handy. More like this, you can ask Solr to tell you what are some other documents that are similar to the document that I'm asking you about. So say you've got a blog post indexed in there, and you might want to list, you know, 3 or 4 that are similar based on the content of the blog that you are doing there. And yeah, there's probably more features in there, but whatever. So those are some of the ones that I've found interesting or worked with in the past. You know, faceted browsing actually was one of the biggest uses of Solr I did with a project last year where we had a data set of about 200,000 documents, and just all sorts of interesting taxonomy in there that you were kind of browsing up and down. So Solr in production. You know, if you're going to run a Solr server, what are some of the smart things you're going to need to do to make sure that you're going to keep things fast? Because Solr is fast. I mean, that's really why we're using Solr, is because, I mean, it's giving us features we wouldn't otherwise have access to, and it's doing a lot faster than our database would. And it's great because we're able to scale our search traffic separate from our database traffic, our actual application server traffic. And yeah, I mean, it's really fast. Here's some fancy charts. This is from one of my servers on WebSolr, where the blue line is our maximum query time. And the average maximum query time there on that chart is 75 milliseconds, which is not too bad when you're considering a web request budget of like 250 milliseconds. I mean, 75 is not great, but consider the 95th percentile, you probably can't see. The average 95th percentile is the orange one below that, and significantly smaller, 11 milliseconds for our 95th percentile query time. So we're talking really fast queries here. Certainly, you know, as fast as most database operations. One thing that you need to consider in production in order to keep these things fast is commits. So when you're adding and updating, your changes aren't actually immediately available in Solr. It kind of keeps an incremental, it does these adds and updates incrementally, and in order for them to show up in your searches, you have to commit them. Just tell Solr, like, hey, go ahead and do the work that it's going to take to have these show up in my results. And that's because Solr does a lot of work in order to, I mean, your searchers, the threads that are doing your searchers are read-only, and it's a little bit expensive to like reload all those caches. And this is all the stuff that happens in a commit. Locks the writer, flushes all the latest changes to disk. It starts a new reader with those latest changes loaded in it, warms up caches, registers that reader so that it can start handling requests, and then tears down the old one and then unlocks. So most of the time, it's not a big deal. We find that a commit can run anywhere from 200 milliseconds up to maybe like 2 seconds if you've got a huge backlog of changes waiting to get flushed out to disk. Most of the time, I mean, the reason the commit exists is because if you're doing a couple updates in a row, there's no point in tearing down and restarting searchers if there's not going to be, you know, if you're not going to serve searches from those new searchers. If you're just going to tear it down and restart again, say you send in 3 or 4 updates in a request, well, there's no point really updating your indexes till the end of a request. And most Solr clients are going to handle this just fine for you. For example, Sunspot. It actually issues its commits in an after filter on the controller. So your models can do a bunch of updates over to Solr, and then when the request is done, if any updates have happened, it'll go ahead and send a commit over to the database, over to Solr, and you'll be good to go. So this only really is a problem if you're, you know, writing your own Solr client or like issuing many commits per second. We've seen commits do terrible things to servers, but one of the ways we deal with that actually in WebSolr is we make commits a no-op, and you can configure Solr to actually auto-commit. So within a second, you know, you make an update within a second or within 10 seconds or whatever you configure, Solr can automatically issue that commit to make sure things do the right thing. So. And again, you know, this stuff isn't going to really impact you most of the time, but sometimes you'll get bit by something like this, and you just kind of remember, oh yeah, commits. Another really interesting operation for Solr in production is the optimize command, and that essentially, you know, as you're committing changes, you're creating new files where all your index data is being dumped into. Optimize takes all those files, opens up a brand new index, just kind of shoves them all back into 1 file or 2 files, whatever you ask for. And this just to make sure that you're not using too much memory. You don't want to run out of memory on this kind of stuff. The really fun part, though, is when you never issue optimize, you will eventually run out of open files that your operating system will let you open. So yeah, that actually, debugging that shows up really very clearly in Google because that bites people kind of a lot. So yeah, you want to do an optimize maybe once a day. It takes, you know, a few seconds to a few minutes, depending on how big your index is. Replication is really fun with Solr because it's stupidly easy. When you're replicating in Solr, it's a pull operation from the slave to the master. So you tell the slave, hey, the master is over here. Go get your data from him. And it knows what to do. It's really smart about it. And the data that gets sent over is just so optimized for the job that, you know, even a multi-million document index is only going to take like a minute or two to fully replicate from scratch. And then from there, it's incremental. So they're just really cheap, and that means Solr is great for scaling to really high I/O sites. If you've got a lot of search traffic, it's so easy to just spin up a bunch of different read cores that all your traffic can go to these read cores and keep things really quick. So it's also important too because it's great to decouple the reads and the writes, because you saw the commits are pretty expensive. It'll block your reads for a little while until things are back up and running. Excuse me, it won't block your reads. It'll block your writes for a little while until things have flushed through the system. It'll generate load on the system that's receiving the writes. But if you have all your writes going to one core and all your reads going to other cores, you never have to worry about impacting the quality of your searches when you're making updates to your index. So that's pretty cool. We've got a couple of customers who have index sizes in the tens of millions with lots of traffic, and replication makes scaling to that just really easy. Caching, I'll just mention this quickly. Each search reader has all sorts of really cool options for caching the index, the actual popular search queries and popular results, all sorts of different stuff. If you're going to run a Solr server, you might want to read some of the documents on this, because this is one of the areas that they give you a lot of rope. I've seen cache warm-ups on cores like take down servers just because all this work's going on, especially if you're issuing a lot of commits. Always just all sorts of churning going on every time you bring up a new search reader. But on the other hand, it is very smart about caching all your results. I mean, that's what it does, is serving back search requests from itself. So yeah, that's a whirlwind tour through Solr. It's a lot of fun, I think, coming from the perspective of kind of a generalist Rails developer. I hope it wasn't too obvious that I'm not a Solr expert. It just makes things, if you're doing search in your app, it makes things a lot easier when you're using a proper indexing search server. It does it a lot faster than your MySQL database is going to do it. And for some use cases entirely, they just wouldn't be possible unless you're actually generating a proper index. So Solr is kind of the industry standard way to do that. And yeah, so that's Solr. Now let's see if there's questions.
So if you're doing, say, plain vanilla full text search on a relational database, any thoughts on Solr versus something like Sphinx and Thinking Sphinx?
Yeah, I would say probably the biggest feature to Sphinx is that it's very easy to set up. Like typically it runs right alongside your SQL database. And in that sense, if you've got dedicated database hardware, you might as well reuse it for your searching as well. And I've used Sphinx only for one, or maybe two. I think only one application I've ever done has ever really used Sphinx. I don't even know if that made it to production. So I'm not an expert on Sphinx by any means. They have a lot of the similar features. But from what I understand of Sphinx and Solr, Solr is it's definitely a lot more cloud friendly. It's a lot easier to, I mean, obviously with Web Solr, we're not Web Sphinx. Like, it's not really possible for us to set up Sphinx in such a way that you can do like easy managed hosting. I've kind of had some conversations with people about this, but that's kind of the answer there. Like, it is very easy to set up compared to Solr. Solr is an extra server, an extra HTTP server that's running. You got to get Tomcat up and running. You got to get it configured. So, yep. So hence why I'm in business selling, making that easy. Sphinx takes fewer resources. Yeah. Okay. So Sphinx will use less memory. Obviously, the JVM is not the lightest VM around, but some people will accuse Ruby of that as well. Back there.
So in my past job, we used Ferret way back when, and it was horrible. Last year I played around with Sphinx, and it was way better, like really nice setup. The only problem was it doesn't do partial updates, so you have to re-index everything basically, and that can be kind of painful if you have it on a cron job every 10 minutes and somebody updates a record and they're like, I can't search for it, and it's like, it's the top of the list, you don't need to. But so this seems like really nice, as you can do, you know, it'll, like after a controller commit, it'll update the index and everything. So I guess my question is, how well does it integrate into Rails, and are there wrappers for it? Does it make it real easy for you to set up, or is the config for Solr already really nice that it'll talk with MySQL and whatnot?
Yeah, typically, you know, different languages, different frameworks have their own Solr clients. It all really boils down to a wrapper for some Ruby commands. I mean, Rob there has actually written his own Solr client, so he's certainly qualified to speak. I really recommend Sunspot for Ruby applications. It presents a really nice, you know, Ruby-ish DSL. It does stuff with blocks and methods. And probably one of the first really popular, if not the first, Ruby Solr, and Rob can maybe correct me on this one too, was Access Solr, which was developed at Mingle a couple years ago. Yeah, so it's kind of old. Yeah, Rob, fill us in on Solr clients.
So right now the landscape, really, if you are doing something in the common case, you want to use Sunspot. If you want to get really close to the metal, or you're not using Rails or models, then Ruby Solr, which is bundled with Solr itself, or our Solr, are both excellent clients for dealing directly with the Solr database in a more programmatic API kind of fashion. Access Solr is dead. Sunspot is its successor. Sunspot's kind of a kitchen sink approach. So if you want a really, really light wrapper between the Solr Ruby libraries and like just a simple model, and you want a lot of control, or you're going to do something really custom, then TanningBed comes in to fill that gap.
Yeah. There are a couple other custom written Ruby client. One of our larger clients has their own. It's so easy to write your own Solr clients because it's really not that many API commands that you have to support. So, but yeah, I would say for the general use case, the 80 or 90%, Sunspot really does the job. Access Solr, yes, it is pretty much dead, but we maintain the gem. So if anyone is using Access Solr out there and you've got features you want to contribute, we're accepting commits for all sorts of stuff. If someone wants to fix the exclamation point escaping bug, let me know.
Does that mean maybe if you're actually maintaining it, maybe we could get the domain pointed to you somehow?
Yeah.
We should reach out to Chiago, because it'd be nice to have that be Googleable again.
Yeah, right. If nothing else, to say, hey, use Sunspot instead.
I get another question. For Sphinx, you just re-index everything, so it goes through the database and just pulls all the fields down and builds the index again. How does Solr build the list of changes that you've done?
Yeah, that's a great question. That is actually, come to think of Sphinx versus Solr. Sphinx will talk directly to your database. It's kind of how it's designed. Solr, because it's an HTTP API, you're posting every document. And that can be a little slow. The fastest, full re-index I've really seen is 100 documents per second, because you are pulling that pulling it out of SQL, serializing into a document. And I mean, especially if you're pulling in associations and indexing your associations in with this document. And that 100 documents a second was someone running 3 different re-indexing tasks on an EC2 large and an EC2 medium or something like that. And that bottleneck was completely at the client side. I mean, it was barely even touching our server. So, yeah, that's how Solr deals with indexing. You just post documents over HTTP, and that's how it goes. So, typically, it's not too bad.
Just as a point of order to address what this gentleman in the yellow shirt said. I don't know your name, sorry. Oh yeah, Sphinx does delta indexing. It has for a while now.
Yeah.
That's not really a weakness anymore, so. That's thinking Sphinx that uses delay job. There's other ways to do it.
Did you have a question earlier? Red shirt in the back. Keep moving around.
So what about the geographic thing?
Geographic. It's oh, what about I haven't implemented any sites with spatial searching. Patrick, actually, sitting right next to you, has. Okay.
Patrick, what about the geographic thing?
This is why I love STRU, because the experts are in the audience. Right.
So yeah, this is Patrick. So yeah, I did use it recently, and it works really well. I think technically it's going to be easier with Sunspot 1.2, which is not quite out yet. But I really didn't have to do very much to get it working. So an example was like, I had like some theaters, and was like, hey, here are 5 theaters nearby, and it worked perfectly.
Yeah. So there are a couple of Java plugins for Solr that do some like index time processing. I mean, people feel free to correct me if you know better. That do like index time processing of different latitude and longitude distance calculation type of stuff. The next version of Sunspot is going to do some of those calculations in the client, like in the actual query time. I mean, essentially, what does spatial search boil down to is you've got latitude and longitude on your records, and you need to do distance searches in radiuses from points. So
It's not going to compete with PostGIS or anything.
not necessarily, no. Yeah.
Of course not.
Yeah. So we had someone without a microphone for the podcast suggest Axe is mappable. But he was talking to someone else, so he doesn't have to buy a spare. Awesome. Anyone else? Questions? You guys make it easy. All right, thanks, guys.